So that'll be 6i. Any idea about the other one?
Not sure.
Let's see. Can you split it up into two different things, like square root of something, square root of something?
You could think of square root of 9. No, that wouldn't work. Not 25 and 3.
Times each other.
25 would give you 5 still. Sorry? Okay, square root of 25.
They
Square root
have
of 3.
to. They have to multiply by each other, so factors of 28.
Yeah. Oh, yeah. 2 and 14, but that won't guess anything.
Mm-hmm.
Not 3, 4 and 7.
Mm-hmm.
Not 5, 6.
You could do 4 and 7, because you can have the square root of 4.
4 and 7. Okay, so 2 root 7, or 2i root 7?
So it could be minus 4 and 7, and so that would be 2i root 7. Let's take a look. 6i and just 2 root 7i. That's how they write it. It's the same thing. 2i root 7, 2 root 7i. And I just want to try something. Calculator. Square root minus 36. Nope, doesn't like it. Maybe there's an option in there somewhere. Okay.
I have a further maths button or something.
How about this one? How do you do these?
A plus bi where? So would it just be simply adding the like terms? So 9 plus 8i for the first one?
Yep. Okay, let's do all of them.
Okay, the second one would be minus 3 minus 3 plus 6i.
I believe so. C.
10 minus 16i. And then D 5 plus 3i.
That's right, so let's see. 9 plus 8i minus 3 plus 6i. 10 minus 16i. 5 plus 3i. That's it. Great, great, great. You're not supposed to use a calculator. Okay, exam question. How do we do this?
Given that z equals a plus 9i, that equals that. Fine. Oh, and z2 minus z1 equals that. Okay. So we just write out the whole thing. So minus 3 plus a plus 9i plus bi equals 7 plus 2i.
So z2 is minus 3 plus bi.
Oh, z2 minus... Oh, I've done it wrong. Yeah, so z2, so minus 3 plus bi minus a plus 9i.
Mm-hmm.
And that equals 7 plus 2i. So then we look at minus 3 minus a, and that should get 7. So a is 10.
7. So a is 10.
And then b would have to be 11, because 11 minus 9 is 2.
I think a is minus 10, because it has to be minus minus.
Minus, yeah.
And then b minus 9 equals 2, so b is 11. Minus 10 and 11. Minus 10, 11. Great. Okay, you can use complex numbers to find solutions for quadratics if b squared minus 4ac is less than 0. You have two distinct complex roots, neither of which are real. Okay, how do we solve this?
Z squared plus 9. So usually we would think of it as maybe 3 and 3.
Z squared equals?
Equals 9, minus 9.
Mm-hmm.
So then Z equals the root of minus 9. So then that's just 9i.
3i?
3i, yeah.
There's one more answer.
Plus, minus.
Yep. Plus
Or
minus.
just, or just 3.
So I think
minus
it's just 3i or minus 3i. And so Z squared is equal to minus 9, and so Z is equal to plus or minus root minus 9.
How can you have a negative I?
How can you have a positive I? Like, let's say, so Z squared is minus 9.
Yeah.
What is, so root minus 9 squared. What will that be?
3.
No. So it's minus 9
3.
square root
Yeah.
squared.
Minus 9. Because they cancel out.
Yeah. How about negative square root of minus 9 squared?
Positive 9.
So it will be minus root minus 9 times minus root minus 9.
So minus 3i times minus 3i.
Minus times minus?
Plus.
Root times root?
Cancel out.
Yeah. And so what are you left with?
9.
Minus 9?
Minus 9.
And what is
Plus.
plus minus the same as?
Minus.
And so these two are the same. So the square of root of minus 9 is the same as the square of the negative root of minus 9. And that's why you have plus or minus, because there's two possible answers. If Z squared gives you minus 9, then Z equals plus or minus square root of minus 9.
Oh, I see. Okay.
It's just the same principle. Plus 3i and minus 3i. Two possible roots. How do we do this?
Equation Z squared plus Z. So we think what goes in 25 is 6 and adds to 6.
I'm using calculator.
Oh, okay.
I'll try graphical as well.
I'm to get in the solver. Just going to see how that goes. No solution, obviously.
But did it not give any what the imaginary numbers are?
No. It just says no solution.
Okay. Where's so a solver's equation? Is it? No, don't use a solver. Use polynomial f2.
Okay. F2. So no real roots.
Did it say what the imaginary roots are?
No. If I could edit, no.
So simple calculator. Do you have
Simple
one?
I do. Somewhere.
So try this one.
Yep. I've got.
So
Oh no, but this one doesn't do quadratics. Like it doesn't do anything.
What one is it? An old calculator?
No, it's one that I was told to buy for the entrance exam so that I couldn't cheat by just simplifying the differentiations with them.
Oh, why would they do that? So you can't use a 991EX, is it?
Is that the...
This one?
I've got... No, basically, the exam that I did was an entrance exam for a school in the Netherlands, which I got into, actually.
Yay, well done.
Well, thank you, actually, for guiding me through the stuff that wasn't taught at school.
Yeah, no
Um,
problem.
But yeah, basically they didn't let me use calculators that had differential solving methods and
Okay.
stuff like that. So there's that. I may have one of the like other ones. I've got this one.
Nope.
No, I don't have anything other than these three.
Okay, so this one will do. You really only need 2, but anyway, 50 snaked you. So it is -3 plus 4, -3, -4.
How do I get it on this one? Because that's the one.
That's the graphical, is it?
Yeah.
I don't know. Let's see, because it's perfectly allowed. But I mean, a graphical really should have.
Should I try it on the graph?
Shouldn't work on graph because it's just not. It's not in the complex plane. I think it's called. Let's see. Edit? No. Solve? No real roots, but see, it says real numbers up there. Option. There's some setting that we have to change so it does imaginary.
Shift, program shift, setup. Oh yeah. Have to go shift
Okay,
setup.
change real to imaginary, is it? Oop,
And then A plus BI, I'm guessing.
that sounds right. Now
And
let's
now,
try it.
yeah.
Yeah, rock and roll, it worked. Okay.
Oh, I've got different answers. Have I done it right?
-3 plus 4,
Oh,
-3
I
plus 4.
put 25 by accident. 20. Yeah, no, I got what I'm saying.
Okay. And that's how we do these ones. There we go. Do not choose your calculator. Ha ha ha. Okay, this one. Hang on. Do I try to find a practice question just so we can have some practice on this stuff? Yeah. Let's see. Yeah, let's try question 5 there.
Okay. Solutions of quadratic are form. Okay, so z squared minus 8z plus 21 equals 0. Without the calculator?
No, with the calculator.
Okay. So 1 minus 8, 21. So 4 plus minus root 5. Those are like the different answers.
That's it. Great. Okay, question 6. Exam question. How do we do this?
The equation is z dx 7 equals 0. Find the possible ranges. Oh, the possible values of b. So z is going to be the same, but that's sort of like x, right?
Yep.
How would we work back from this?
Find the range of possible values. It has distinct roots. What does that tell you?
It's got 2.
Yep. non-real complex. What does that tell you?
It's in the non-real plane, so it's going to be an I.
Yeah, and when does that happen?
When the number is a negative?
Yes.
When it's like a negative root?
Yes. What part of the... So you can solve any quadratic using the quadratic formula. What part of the quadratic formula is in the square root?
I've forgotten the name. There's the part that's also useful for finding other stuff, like the nature of the quadratic.
Discriminant?
Yes, discriminant. So do we just plug that into the discriminant?
Yep. What is the discriminant?
So root b squared minus 4ac.
Yeah, you don't need the root. What do you know about...
Okay.
So you said it's negative, and the way you can represent that is it is less than 0.
Less than 0.
So b squared minus 4ac is less than 0.
Mm-hmm. So we know that a is 1 and c is 11. So b squared minus 4 times 11 less than 0. So b squared minus 44 is less than 0.
Mm-hmm.
So b squared, we could say is less than 44. So b is less than root of 44.
So b is less than, and I think it's going to be plus or minus root 44.
Oh yeah.
But there's a way, I think it's going to be, actually b will be less than root 44, and it will be greater than minus root 44. The sign changes, and so b is between minus root 44 and plus root 44. And we could draw a graph.
But would you not just say, instead of having it as b is less than root 44, could you just say that b is less than 0? Oh wait, no.
B squared minus 4ac is less than 0. B squared minus 44 is less than 0. And so b squared is less than 44. And so
Okay.
if we... So I'm going to go back to this calculator. Menu, inequality, degree 2. We have less than, so that is 2. B squared, so the squared thing is 1. The thing in the middle is 0, and then this is minus 44. And square root of 44 is 2 root 11. And so b is in between minus 2 root 11 and plus 2 root 11. Or it's in between root 44 and minus root 44. So you could do a graph as well. I'll do a graph. Let's see. Graph. Menu. Graph. I have to do these. So b squared minus 44. So I'll just do x squared minus 44. Can you see okay?
Let me just get a charger. Yeah, let me just get a charger.
Sure.
Okay. This should be better.
Let's see. So, yeah, x squared minus 44. If you draw the graph, if you draw the graph of x squared minus 44, Shift graphical solve. The roots, it is in between minus 13.6 and plus 266.
And the discriminant, what does it show again?
The discriminant shows the number of roots. So it's basically when we say like two distinct real roots, one repeated root, and then we say no real roots, that's because there's two. That's because there's two imaginary roots. So when it's less than 0, no real roots, but two imaginary roots, and this is them. So b squared minus 4ac is less than 0, a is 1, c is 11, b squared minus 44 is less than 0, and you can do that as a graph if you want. I did x squared minus 44, and you can see how when is the graph less than 0? It's less than 0 in between root 44 and minus root 44. So that's just what that looks like. I can go there. Yeah. Or you can do it the way I did it originally. So we just said b is less than plus or minus root 44. Not quite. B is less than plus root 44, and then it flips for the negative. B is greater than minus root 44. Any questions there?
No.
Tricky. Okay. They said 2 root 11, and that is because if I go back here, root 44 is the same as 2 root 11. Okay. Multiplying complex numbers. Let's try this.
Following from A plus B numbers.
Oh, hang on. Do we did I call you an hour early by mistake?
No. Oh, yeah. But it doesn't matter because... Oh, wait. Do you have a mocha now?
I'm supposed to have a mocha now. What am I doing? Hang on a second. I'll just message her.
Okay.
Go on, try this question.
Okay. Okay. Oh. Okay. I think I've got it.
Okay, what is it?
So when you do 3i times 5i,
Yeah.
it becomes minus 15 because I squared equals minus 1.
Well done. So that is minus 15.
And then you just add minus 15 to the 8, and that gets minus 3 plus 22i.
8 minus 15, so that's
Oh, wait,
minus...
no. That's minus 7.
And then 10i, 12i, was it 22i?
Yeah.
2i minus 7 plus 22i. Yep, great. Okay, let's try these.
It's odd because I was under the impression that my lesson was at 5 as well, not 6.
Oh, why is that?
I don't know. I just had the impression that it was.
I think we've been in this lockdown for too long. We just lost all sense time.
I cubed, would that be just minus I?
Yep, minus I.
I to the 4 equals I.
Let's think about this.
Minus 1.
So it's going to be -1 times -1, I think.
Yeah.
What is -1 times -1?
Just 1.
I think that was just 1. And see.
2I to the 5. What's 2I squared? That would be -2. Would it not?
Well, it's going to be 2 to the 5. So that's 2, 4, 18. That's 32. Because it's in a bracket, so it's both of them to the 5. And then I to the 5 is I to the 4.
So it's 1 times I. So just I.
1 times I. So I think it's just 32I. So that one's -I. That one's 1. And that one is 32I. Yeah. And so we just... Yeah, you can always just do it the long way by putting it as square root of -1 times square root of -1 times square root of -1 and doing it that way. Let's see. Okay, exam question. And what is this one?
So about 1 minus 4I is the solution to this that equals 0. Is this sort of like back in polynomials where you would substitute in the value of I, Z, or whatever, find A is equal to 0?
Yeah.
Okay. So first off, we do 1 minus 4I, all of that squared, minus 2 times 1 minus 4I plus 17 equals 0.
Well,
But we have to solve it.
Yeah, we won't make it equal to 0 yet. We'll just work it out.
Okay. So we get 4I plus 1 minus 4I.
How'd you get 4i?
Plus. Sorry?
How'd you get 4i?
Because we're squaring 1 minus 4i.
Yep.
So I did 1 times 1, which is 1.
Mm-hmm.
And then it's 1 times minus 4i. So minus 4i.
Minus 4i, okay.
Then minus 4i again. And then plus 16. Minus 16.
Yep.
Yeah. Then minus 2 plus 8i plus 17. So that becomes no I.
Mm-hmm.
Then plus 1 minus 16 plus 17. Which doesn't equal 0. Equals 2.
Let us say 1 minus... what is 1 minus 18?
18.
Minus 16 minus 2.
Oh, I didn't see the 2. Okay. Yeah, that works now. Then this one. 0.
Equals 0. Therefore, Z equals 1 minus 4i is a solution. That's it. You just sub it in.
Mm-hmm.
Okay, multiplying complex numbers.
I think I'm getting there with it. It's just, yeah, the powers, and when you square it together, that makes it tough.
Okay, what's this malarkey? Complex conjugation. For any complex number, the complex conjugate of the number is defined as the negative thing. So a plus bi, the complex conjugate is a minus bi. And z and z star are called a complex conjugate pair.
This is like inverses when we had to go from x to y, being the power and stuff.
Maybe. Okay. What is this?
Given that z equals 2 minus zi, so z star would be 2 plus zi.
Yep.
Find the value of z plus z star. So 2 minus 7i plus 2 minus 7i plus zi. So then the zi's cancel out and then it's just 4. Find the value of z times z star. So 2 minus 7i 2 plus zi. And does it work both ways? If z was z plus zi, the other one would be z minus.
Yep.
Okay. So 2 times 2, 4, then plus 14i. Plus 42i,
Okay.
I believe. Minus times minus. Yeah.
So 49i squared, is it?
Yep. 49i squared,
So,
which just becomes minus 1.
Yep.
Well, it's minus 49 times minus 1.
Oh, you're
Minus
right.
7.
Different signs. They're different signs. So it's just plus 49?
Yeah. And then minus 14i again. After, because minus 7 times 2 is minus 14.
Yes. Minus 14i.
Oh, and one of the 14i should be a plus.
Yeah, they're different signs. What do I keep thinking? Oh, I'm so used to doing square brackets.
So then the 49's cancel out, then it's just 4 plus 49. So then it's just 53.
53. Let's see. 2 plus 7i, 4, and 53. 2 plus 7i, 4, 53. Let's see. So quick way with this complex conjugate thing, complex conjugate pair, is first number squared plus just a number part squared. So 2 squared plus 7 squared. That's a quick way of doing that one. Quick way of doing this one is just adding 2 plus 2. Okay. Any questions there?
No.
It's all right. Oh, what is this? For any complex number z, the product of z and z star is a real number. Okay, so how do we do this thing?
So for any complex number, the product is a real number. You can use this to divide two complex numbers. Okay. So, and then divide the result. So they want 5 plus 4i over 2 minus 3i times 2 plus 3i.
Not just 2 plus 3i.
To do this, you multiply both the numerator and 2 plus 3i over 2 plus 3i.
Yeah, so it's nearly identical to rationalizing the denominator with surds. So what's the bottom bit gonna be?
So the bottom is going to be 4 plus 9.
Yep.
And then the top is going to be something. So 10 plus 3i plus 8i plus
Hang on, 10, 10
minus 12.
You said 10 plus 3i.
Yep.
Is it plus 15i?
Yeah, that's what it's meant to be. 50i plus 8i minus 12.
I think so.
Then that is minus 2 plus 23i over 13.
Over 13. Hopefully that's alright. Minus 2 plus 23i over 13, and they separated them out. So they separated that into minus 2 over 13 plus 23 over 13i, so that you have one real number and one imaginary.
Okay.
Any questions there?
No. I think it's just remembering the formula. So know which one to use.
This one is nearly, if this was surds, what if I said it was 5 plus, wait, it's going to be a bit weird. 5 plus root 4 over 2 minus root 3. What would you times the top and bottom by?
2 minus root 3 over 2 minus root
3. 2 plus root 3.
Yeah.
And so you can see how it's nearly exactly the same. Instead of root 3, it's 3i. You're changing the sign. Yeah, it's the exact same idea. You're just trying.
If you do it with surds, is it the same sort of rule where it's the first number squared times second number squared?
Yep, I think it is. I think the bottom would end up being 13. Or it might actually be 2. It might be minus though. Hang on. So it might be 4 minus 9. Yeah, it'd be 4 minus 9 on the bottom if it was surds.
Okay.
Given that this is equal to this, find z in this form. That's not easy.
5 plus 2i over z equals 2 minus I. Find z a plus bi. Could we bring it down to 2i to make it equal to 0?
2i. I'd probably just rearrange to make z the subject.
Okay. So 5 plus 2i over 2 minus I equals z.
Yeah, 5 plus 2i over 2 minus I is equal to z. And then we need to put it in this form.
Yep. So we need to do what we did in the last example. So 5 plus 2i over 2 minus I times 2 plus I over 2 plus I. So that gets you 4 minus 1.
On the bottom?
Plus 1.
4 plus 1.
And then you get 10 plus 2i squared, which would be minus 2. Plus 4i. Have I done something? No, I've done something. No, I haven't.
Yes, you have.
I've done one part wrong. Okay, so 10 plus 5i plus 4i plus minus 4.
This is 1i over here.
Yeah, so then minus 2.
Minus 2, yeah.
Yeah. I did the wrong way around earlier. So then it just becomes 9i plus 8 over 4 plus 1.
Mm-hmm.
And then, I don't know, just over 5. I don't know how you can simplify it. Split out the i's.
Yeah, split them up.
So 1 and 3/5 times 9 over 5i.
Yeah, and you don't need to do anything fancy. 8 over 5 plus 9 over 5i. What is A? What is B?
So a equals 8 over 5
Mm-hmm.
and b equals 9 over 5i.
Just 9 over 5. Yeah, just that
Okay.
number in front of I.
Oh yeah, because b is in the form of I, right?
Yeah.
Okay.
That's it. Any questions there?
No?
Okay. Let's see. The complex conjugate. The complex number satisfies this equation. Find Z. Okay. How do we do this?
Satisfies the equation, find z. Okay. So 4 plus 2i z minus 2i equals 6 minus 4i. Find z, give me your answer from a plus b, where a and b are rational numbers. So I guess we want to extract z from the equation. I was thinking you maybe multiply brackets together and then identify z by itself and bring it over.
Yep.
So multiply brackets first.
Mm-hmm.
4z minus 8i plus 2iz plus 4 equals 6 minus 4i. Would you want to factorize this?
Yeah, very good.
So 2z, then 2 minus 4i plus I plus 2 equals 6 minus 4i.
And I'm actually just going to factorize out Z.
Not 2z.
Because the reason why is because we actually want find Z, not so it's actually just a simpler thing.
Okay.
Okay.
Yep.
What's next?
So then you just bring everything from the left to the right. So you just divide. Well, the first 8i plus 4 you add.
Yeah. What would you get?
So then you get z 4 plus 2i equals 6 minus 4i plus 8i minus 4.
Mm-hmm.
And then you divide by 4 plus 2i.
Yep. What do you get when you do your adding and subtracting?
So then you get 2 plus 4i over 4 plus 2i.
Yep. 4 plus 2i.
And then you can break that down to 2 over 4. Ooh, wait, no. Yeah, so half times 2i. So just I.
A half plus 2i.
Plus 2i.
Yep. Z equals a half.
And then A equals B equals 2i. 2.
Yep, that's it.
Okay.
Any questions there?
No.
That's very good. Let's see this one. Let's just do the start of it. I think once you reach the important bit, you'll be fine. Let's just hope to start it.
The complex number 7. So 1 equals p minus 7i. Z2 equals 2 plus 5i. Find Z1 over Z2. So then p minus 7i over 2 plus 5i. And then you just 2 times 2 plus 5i over 2 plus 5i.
Something's wrong. That would be squared, wouldn't it?
Minus 2 minus 5i.
Yes. And so that is times by 2 minus 5i over 2 minus 5i. Yep. And then you just get your answer. So, yeah, I was just checking that would be 2 minus 5i top and bottom. Let me see this thing. Z is this. Z star is the complex conjugate. Show that. Oh, okay. How would you start this one?
Conjugate equals that where a, b are rational numbers to be found. So we do the root 5 plus 4i over the root 5 minus 4i times root 5 plus 4i over root 5 plus 4i.
Hold on. Root 5 plus 4i. Hang on. We did something wrong back here. This is wrong. If there's one thing on the bottom, this will work. Can't do this. No. We need one thing on the bottom. So what would you have to do to this?
Which one are we looking at? Oh, this one.
So you can half the top and bottom. 1 plus 2i over 2 plus I. How could you put that in the form a plus bi?
A plus bi. Half. I mean, you could cancel the I from the bottom, from the top, so that it becomes 1 plus 2. 1 plus 2 over 2.
If you have one thing on the denominator, you can do that. But if you have two, then you can't do that.
Okay, so yeah, then we do the 2 minus I.
Yeah, and then you would just get your answer.
Mm-hmm.
So just watch out for that. Yeah, if there's one thing on the bottom, then we can split it up. If there's two or more, then we can't. That's fine as well, I believe. Yeah, there's nothing. There's just multiplying after that. I think there's nothing especially difficult. Let's see. Find the value of p, the complex number, given the real part is a half. Any idea how we're doing this one?
The complex number z is defined as z equals p plus 5i over p minus 2i. Given that the real part of z is half, real part. So what? I'm not too sure. What? So do we just put half equals p plus 5i over p minus 2i?
Nope. You write it in the form a plus bi. So you want to write it in that form.
Oh, but then what does the half part mean?
We'll get there.
Okay. So times p plus 2i over p plus 2i.
Yeah.
So then that gives us p minus 2 plus 2 over p squared plus 2ip plus 5ip minus 10.
It's 10. And the bottom is p squared and
It's p squared.
on the bottom is it p squared?
I thought it's just the first two numbers, yeah. So p squared plus minus 4.
It's 4. Yes. What does next?
I thought that was the whole of the denominator, right?
Yep.
So then p squared plus 7ip minus 10 is the top part.
Yeah, p squared plus 7ip minus 10. Okay, what is next?
We can cancel out the p squares.
No, there's more than...
Do we have to do another one?
What do you mean by that?
So multiply it by p squared plus 4 over p squared plus 4.
That feels like just going in circles.
Yeah.
I think we factorize.
Factorize.
Yeah. What will the bottom? What will the bottom
The
factorize?
You can't really factorize because they don't have like terms.
P plus 2, p minus 2.
Okay.
Can the top factorize?
Yes. 2 no. Minus 10. 2 and 5. Yeah. P minus 5, p plus 2.
Let's see. No, top won't factorize at all, will it? What am I missing here? Did we do this right? Okay, we said p minus 2i, p plus 2i, p squared. So I think I'm okay with that one. Then the bottom bit will be p squared plus minus and then minus 2 as minus 1 is... Should this be plus 4 on the bottom?
Minus, yeah.
That should be plus 4. So the bottom doesn't factorize that way. P squared plus 4. Let's see. Yeah, I think I see it. P squared plus 4 is on the bottom. Whoops. P squared plus 4 is on the bottom. They tell us, so if we were to split that into the real part and the not real part, it would be p squared minus 10 over p squared plus 4. And then plus the bit that is not real, the imaginary bit, 7ip sorry, hang on. I'll write it as 7p over p squared plus 4i.
Okay.
What did they tell us about the half?
Said the real number is equal to a half. So p squared minus 10, p squared plus 4 is equal to a half.
Yeah.
Okay.
And so that's what you're solving.
So we want to find p. Uh-huh.
Yeah.
How I go from here? Multiply. No. Factorize. No.
I would just multiply both sides by the denominators, so it's not a fraction anymore.
Okay. What? So p squared minus 10 times p squared plus 4.
So it would be 2 times that one is equal to 1 times that.
I don't get that intermediate part.
I times both sides by p squared plus 4 and 2. Cross multiply.
Oh, I see. Yeah. Yeah. I don't know why I didn't see that. Equals p squared plus 4. So then multiply out on the left-hand side.
Yep.
So 2p squared equals minus 20. Equals p squared plus 4. And then bring it over to... So we bring the p's to the left and the normal numbers to the right.
Mm-hmm.
So 2p squared. Oh, there'll be two numbers. So 2p squared minus 24 minus p squared.
Mm-hmm.
0.
Mm-hmm.
So that just becomes p squared equals 24.
Mm-hmm.
So then p is equal to, what did we say before? Not 9. 4 root 5? No, 2 root 5.
Yep. Or just root 24.
Okay.
And it would be plus or minus, but it is a value of p. P is greater than 0.
Okay.
Okay, and then write z in this form. How would you then write z?
So right, so it's in that form. So we found p. So we're just substituting p and then do the big multiplication again.
Yeah, you would just sub it in there. And so we know that the real part is a half. So it'd be a half and then plus 7p would be 7 root 24 over root 24 squared is just 24 plus 4, 28i. There we go. Any questions about that?
For part B, you said half plus 7 root 24 over 2i. 28i.
Yeah, I just subbed root 24 for p.
Could we not use the equation at the top where it says z equals?
They wanted it in this form.
But if we... Let's see.
So we would
Oh,
have
yeah,
to...
it moves on to the same thing. Yeah.
Yeah, so we already did the work for that. And so
Yeah.
we can just use what we did. Any other questions?
Regarding that, no.
Okay, so that's a one marker at the end. That's why I was... because you already done the work. complex conjugation.
I think it was pretty good.
Yeah, so that's roots of quadratics. We did some of that as well. Yeah, so anything in particular you want to do next time, Andre?
Is there
There's more.
anything?
There's more complex number stuff.
Mm.
Roots of quadratics, and you have to interpret the roots and stuff. Okay. And solving cubic and quartics with imaginary numbers.
If we could make a note of doing that, but also finding the area of 3D shapes using integration. I remember that. I got a bit stuck on that in the entrance exam.
Volume of 3D shapes, is it?
Volume, yeah. Using integration.
Yeah, I think it's volume of solid of revolution. I think that's what that is.
What they did was, if I remember correctly, they gave me kind of like a cone, or like, something with asymptotes.
It looks like a vase, is it?
It kind of like stretched out to infinity, and they asked me a difficult question about it. I can't remember off by heart.
Okay, I'll look it up.
Okay.
Any questions for me in general?
No, that's it.
All right, well done, Gregoire. You did great. I look forward to chatting again next week. I'll try to remember to phone S6.
Thank you, and I'll try to remember as well.
All right, have a good week. Goodbye.
Thank you. You too. Bye bye.